Okay, so number one, you're finding the domain and range of the absolute value function. Remember, the domain are your y values, no, your x values, while my brain is working. So I can see here that this graph is obviously going to the right and left infinitely. So we know the domain is all real numbers, or from negative infinity to positive infinity. The range, however, is not. We can see here that the lowest this graph goes is the point -3 and -2. Now remember, the range are your y values. So I'm looking specifically at this -2 here, and then obviously my graph is going up. So since there is a point there at -2, I'm going to square bracket -2 to positive infinity, domain and range. Number two, increasing and decreasing. Remember the analogy I made with a roller coaster. As silly as it is, it works. So increasing, starting over here, going in this direction, that's obviously increasing. Now that is negative infinity, and it stops. Remember we talked about yesterday how we're only using the x values when we're talking about increasing and decreasing. So it is increasing from negative infinity to 0. And then on the flip side, that would be decreasing so it's decreasing from 0 to positive infinity. So increasing and decreasing. Remember, you use those x values, not the y values. All right, number 3, 4, 5, 3, 4, 5. You're going to use that one note paper that's had the formulas on it. That's going to be your best bet on this one, if you want to utilize that. But remember, we talked about the difference between adding or subtracting in the grouping symbols and adding or subtracting outside of the grouping symbols. So we're taking this quadratic and we are translating it. Remember, inside the grouping symbols, that's a horizontal left or right shift, and that plus sign is opposite. Remember, the horizontal shift is opposite. So this one actually moves left 5. But your vertical shift, which is the number that is outside of the grouping symbols, is the one that makes sense. So minus is going to be down 9 units. So the vertex of this graph is going to go left 5 and down 9. So reflection. Remember, the x-axis reflection means the whole thing is negative. So I'm just going to put a negative basically in front of the 3x minus 4. So if I did that, or that's a 3x plus 4, my bad. It's just kind of like you would be distributing the negative. So the solution to that one is g of x would equal negative 3x minus 4. And that's going to be a reflection over the x-axis. 5 and 3 are opposites of each other. This time they're telling me the translation and I have to write the function rule. And again, it is a quadratic. See, here I can see it's a quadratic. So the function rule, so g of x would equal, inside the parentheses, left 6, I know I'm going to use a plus sign. So x plus 6 squared because it's a quadratic. And then down 5, so that's going to be minus. So minus 5. All right, number 8, we are graphing this lovely piecewise function. So I'm going to come down here to my graph paper. Piecewise functions, yay, okay. Ooh, one of them has a 12. Great, we love that. So the first one is just, I really should have put y's in front of all these. Y equals 6. So if you recall, that is just a horizontal line. So I'm going to make my little tiny table, right? And if you look at the constraints next to it, the constraints are from -8 to 1. So -8 and 1. And y is 6, so 6 and 6. Ugh. Wow, this one has big numbers. I don't like that. 16 is the largest I can go. I'll make sure and tweak that for the quiz. I don't want to have to count to 16. Nobody wants to count to 16. The heck? Okay. So let's see how far we can go with this. So this part of the graph, -8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. -8 and 6 is here. And then 1 and 6 would be here. So that's the first piece of the graph. And notice I did both closed circles because both of these are equal to's. So that's the first piece. Let's look at the second piece. Maybe it'll be nicer, probably not. So the second piece is y equals -2x. Again, I'm gonna make my little table. And if you would look at the constraints for that one, this is the one that's not gonna be nice. I'm gonna have to move my graph down. Is 1 is less than or equal to x. Oh, wait a minute. Guys, I made a mistake. I can read. Okay, let me set back. So right here on this one, this is just a less than. So let's fix that. That's just a less than, which is then going to change this end of the graph. Ooh, waiting for that whole thing to go away. That's going to be an open circle there. Okay, there we go. I'll pay attention one day. Okay, so there we go. Going back to the second piece, I've got to use the 1 and 8, and you're multiplying both of them times -2. So -2 times 1, and then -2 times 8, which is where that -16 comes in. So the 1 is a closed circle. So 1 and -2, 1 and -2 is going to be here. Did I make another mistake? I did. It's late. My brain is not working. I can count, just not today. 1, 2, 3, 4, 5, 6. Okay, that should be here, not -1. That's a +1. There we go. Fix that. And then the other one was 8 and -16. The heck? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's all the way down here. But that's supposed to be an open circle. Yes, because it's just less than 8. So that's going to be an open circle down there instead. And so that's the second piece of the function. There we go. That's great. All right, let's look at the last piece of this function. So the last piece of this function is y equals -2 plus x. Okay, this one's going to be much nicer because my constraints are from 8 to 12, and I'm just subtracting 2, so that's not bad. So 8 to 12, but I'm subtracting 2, right? So that's like -2 plus 8 is 6, and -2 plus 12 is 10. Again, now both of these are closed circles, so I'm good on those. But 8 and 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6 will be here. And 12, 9, 10, 11, 12, and 10. It's going to run right into where I have my writing. 5, 6, 7, 8, 9, 10 is actually right here. So that's the second piece. The trick, remember, is to just do it in pieces. Just do that one in pieces. Wow, that was a very big number. Okay. All right, the piecewise function. And then number 7 really should have been back up here with numbers 1 and 2, but technology. It's just asking what are the relative or absolute maxima or minimum. So in this particular graph, this one has an absolute minimum at the point -1 and 1. And that's all of that one.